Good morning, dear student. Today we will see the chapter 1 of the spectroscopy. It is a very basic chapter. Before attempting to deduce the structure of an unknown organic compound from an examination of its spectra, we can simplify the problem somewhat by examining the molecular formula of the substances. So purpose of this chapter is to describe how the molecular formula of a compound is determined and how structural information may be obtained from that formula. So let us see the elemental analysis and calculation. So first step is qualitative elemental analysis. Now to find out what type of atoms are present in the given organic compound. For that purpose, different tests for different elements are available. And for example, if we burn the substance in presence of excess of oxygen, then after combustion, if we get the carbon dioxide gas, then carbon must be present in the given organic compound, and we know that organic compound contain the carbon. Hydrogens are the essential elements. Then oxygen also combines with the hydrogen also combine with the oxygen to form the water. So the formation of carbon dioxide and water by the combustion method, we can deduce that the presence of carbon and hydrogen in the given organic compound. And the formation or the carbon dioxide and water can be detected by the gas chromatographic methods. If the sulfur atom is present, or before nitrogen atom converted, nitrogen atom often chemically reduced to nitrogen gas first, and then this follows by the combustion to give the nitrogen oxide. Then if the oxygen is there, oxygen can be detected by the ignition of the compound in an atmosphere of hydrogen gas. Ignited organic compound is ignited in presence of hydrogen. So formation of water will be there. It indicates the presence of oxygen. Then sulfur atoms are converted into the sulfur dioxide, SO2. So these all are the gases, and these gases are detected by the gas chromatography. And the halogen, there is a special test for the halogen, organic compound containing the halogen. That compound reacts with the AgNO3. It forms the precipitate of AgX, and that precipitate indicates the presence of the halogen in the given organic compound. So from this data we can say which kind of atoms are present in the given organic compound. And from gas chromatographic techniques, even amount of the gases formed is also deduced, and from that amount, that is if amount of original sample known to us, amount of original sample taken for the qualitative analysis, then we can calculate the percentage composition. So let us see how to calculate the percentage composition from amount of gases formed. So let us see the next calculation of percent composition. Consider we have an organic compound which contains carbon, hydrogen and oxygen. We don't know the amount of carbon, hydrogen and oxygen present in it. After the combustion with excess of O2, it forms carbon dioxide plus water. Now by using gas chromatographic techniques, we can determine the amount of carbon dioxide formed and amount of water vapors formed here. And from the weight of the organic compound, for example, we have taken 9.83 milligram of substance for the element detection, then we get the 23.26 milligram of carbon dioxide and 9.52 milligram of water here. So let us calculate millimoles of carbon dioxide from here. So first, millimoles of carbon dioxide form here. So amount of carbon dioxide formed is 23.26 milligram upon its molar mass, that is the molar mass of carbon dioxide is a 44.01 milligram per mole is equal to 0.5285 millimoles of CO2 form here, carbon dioxide form here. So, we know the 1 millimoles of carbon dioxide contain 12 milligram of carbon. So, therefore, 0.5285 millimoles of CO2 contain how much milligram of carbon? So, we have to determine the milligrams of carbon present in our sample. So, let us do the cross multiplication. So, 0.5285 into 12 milligram of carbon upon 0.5285 millimoles of CO2 is equal to how much milligram of carbon. So it comes, so unit of this is also the millimoles of CO2. So the millimoles gets cancelled and it comes out as 6.35 milligrams of carbon in sample, in the sample. Now, milligrams of carbon is equal to 6.35. So write down 6.35 milligrams of carbon in original sample. From that, percentage of carbon is equal to milligram of carbon, that is 6.35 milligram of carbon upon weight of our original sample, that is 9.83 milligram were taken for the analysis. Milligram of sample, it comes into 0, so into 100, because this much amount of milligram of carbon, that is 6.35 milligram of carbon is present in the 9.83 milligram of sample. So how much milligram of carbon in the 100 milligram of sample, that is the percentage of carbon, and it comes out as a 64.6%. Then second is hydrogen. So first calculate the millimoles of H2O form. Millimoles of H2O form in the combustion experiment first. So millimoles of H2O form is amount of sample taken for the analysis, that is millimoles of water form, milligram of water form while doing the combustion experiment is 9.52 milligram of H2O were formed upon the molar mass of the water is 18 milligram per mole. It comes 0.528 millimoles of H2O. Once we get the millimoles of H2O form, we can calculate the millimoles of hydrogen present in it. So the 1 mole of H2O, 1 moles of H2O, millimoles of H2O contain 2 milligrams of hydrogen. Therefore, our millimoles are 0.528 millimoles. H2O is formed here. So, how much milligram of hydrogen will be there? So, do the cross multiplication. 0.528 into 2 upon 1 is equal to dash milligram of hydrogen, and it comes 1.06 milligram of hydrogen in original sample. So from the milligram of hydrogen, we can calculate the percentage of hydrogen present in the given organic sample. So the milligram of hydrogen, that is 1.06 milligram of hydrogen upon the weight of sample taken for the analysis, that is 9.83 milligram sample were taken of sample into 100 is equal to 10.8%. So the given organic compound contains the 10.8% of hydrogen. So from the data, that is the percentage of carbon and percentage of hydrogen, the total percentage is not the 100%, means the remaining percentage is contributed by the presence of oxygen. So let us calculate the percentage of oxygen is equal to 100 minus 64.6 plus 10.8, that is the percentage of carbon and percentage of hydrogen, and it comes out as a 24.6%. 24.6% oxygen is present, and from the percentage of carbon, percentage of hydrogen and percentage of oxygen, we can calculate the empirical formula, and from the molecular weight, from molecular weight and empirical formula, we can deduce the exact molecular formula. So let us see further. The second step to calculate the molecular formula is to calculate the empirical formula first. For the empirical formula, we must know the percentage of elements present in the given organic compound, and that for example, the given organic compound, previously we have calculated the percentage of carbon, hydrogen and oxygen, that is the percentage of carbon is 64.6%, percentage of hydrogen is 10.8% and oxygen 24.6%. The sample taken for the analysis is 100 gram obviously. So these are the percentage. So first calculate the gram of carbon present, means this amount 100 gram sample if we have taken for the analysis, then that percentage means the amount of gram present. For example, the 64.6% in 100 gram means 64.6 gram in 100 gram of sample, and hydrogen also 10.8 gram in 100 gram of our sample, and similarly the oxygen to 24.6 gram in given organic compound, and the total comes out the 100 gram. Now first step to calculate the empirical formula is calculate the moles of the element. So first element is the carbon. So let us calculate the moles of the carbon is equal to its gram weight, that is 64.6 gram, upon its molar mass, that is 12 is the molar mass of the carbon, exact is the 12.01 gram per mole, and it comes out 5.38 moles of carbon. Means in our organic compound 5.38 moles of carbon are there. Then moles of oxygen, or second moles of hydrogen is equal to the gram weight, that is a 10.8 gram, and its molar mass is 1, exact is 1.008 gram per mole, is equals to 10.7 moles of hydrogen. Our given organic compound contains 10.7 moles of hydrogen. Then moles of oxygen, the gram weight of oxygen in given organic compound in 100 gram is 24.6 gram, upon its molar mass is 16 gram per mole, is equals to 1.54 moles of oxygen. So the total moles of carbon are 5.38, hydrogen 10.7, and oxygen 1.5. So from these moles constituent, let's write the result. So it gives carbon 5.38, hydrogen moles 10.7, and oxygen comes out 1.54. So these fractions we can convert into the simplest ratio by dividing the smallest moles. Means oxygen having the smallest mole, that is 1.54. So divide each moles of the element by 1.54, 1.54 and 1.54. So it comes out carbon as a 3.49, hydrogen 6.95, it's almost 7, and oxygen comes 1. So which approximate as a carbon 3.50, hydrogen 7, and oxygen 1. So the empirical formula, or the which approx the empirical formula as a C means multiply by 2. So we will get the empirical formula like the C7, H14 and O2. So this will be the empirical formula for the above percent composition. And if we have the molecular weight, then we can match the empirical weight, or by multiplying an integer to the empirical weight, and we will get the exact molecular formula. So in next lecture we will calculate the molecular formula, exact molecular formula from the molecular weight. Till that time, please subscribe, share and like the videos. Thank you.